So hello everyone. So today we will start about mole concept. So what is essentially mole concept? To beginning, we should know what is one mole. So what is a mole? Mole is a measurement quantity. You may be surprised, sir. It is a measurement quantity. How come? Like suppose kg, weight kg. So 1 kg of something is equivalent to something. Similarly, 1 mole of something, 1 mole of suppose oxygen, 1 mole of hydrogen, 1 mole of carbon dioxide means something. So, what is that something? We will delve into the much deeper concepts in the subsequent lectures. Okay, and we will also apply a numerous number of problems so that our concept gets clear. Okay, so what is 1 mole of H2 and 1 mole of O2 are they same? So before diving into the concept of what is 1 mole of H2 and 1 mole of O2, suppose I say you 1 kg of rice and 1 kg of lentils. Okay, so are they same? Not necessarily. They are not the same, but their weights are the same. Their weights are same. Similar application can be uh, deciphered in the case of in your mole concept. Like, what is 1 mole of H2 and 1 mole of O2? Are they same? Not necessarily, but the quantities they are the same. Means the quantity of H2 and the quantity of O2 is same. But we can't compare 1 kg of rice with 1 kg of lentils because they are not essentially the same. So what is 1 mole? And how many particles or how many atoms or how many molecules do they have? Suppose I say you 1 mole of H2 gas. You know H2 is a gas. So is this first of all, we should know what is the difference between an atom and a molecule. Okay. So atom is the indivisible particle. Means you know this. 1 minute. Atom is like that is a nucleus, and the electrons are roaming around it. So this is an atom. But this not necessarily always atoms take part in a reaction. Okay, atoms don't take part. Some atoms do take part, like xenon, then all the noble metals. But maximum your maximum I forgot it, like sodium also sometimes take part in the reaction in indivisibly. Calcium also does, so sometimes. So but maximum of the molecule, maximum of the entities in the chemistry are in the shape of molecules, like O2 molecules and H2O molecule. Now sir, you will say that what is the difference between an H2O molecule and an O2 molecule? Both are molecules. So what is the difference? See, H2, here is an H2, this is an O2. And suppose I write another molecule, suppose H2. What is the difference between these three things? H2 is a homogeneous molecule. Why I am telling it as a homogeneous molecule? Because the atoms here are the same. Means two atoms of H bond each other. We will go into some details afterwards. So what type of bond is being made? But presently we did not know what type of bond it is. It's basically covalent bond. I'm just sharing the information for with you guys. So H2 is a homogeneous molecule because the atoms are the same. Similarly for O2, the atoms are the same. So it is a homogeneous molecule. But in the case of H2O, what we see that it has two hydrogen atoms and one oxygen atom. So can we say that it is a homogeneous thing? Certainly not. It is a heterogeneous molecule. It is a heterogeneous molecule. Okay, fine. So, sir, what should we do now? We know that it is a homogeneous, heterogeneous. Nothing much. It is just for your understanding what is a homogeneous molecule and what is a heterogeneous molecule. You just need to apply your basic sense. That's enough. Okay. So, sir, 1 mole of H2 and 1 mole of O2 are they same in what quantity? Means the example I gave you, 1 kg of lentils and 1 kg of rice, they are same in what thing? They're numerically same. Means 1 kg of this thing is equal to 1 kg of that thing. Okay, so we can see that 1 mole of H2 has the same number of molecules or atoms that of O2 molecules. Now see, H2 is a molecule, so it will have the same number of molecules that of this O2, because O2 is also a molecule. So sir, we know that 1 kg is 1000 grams, or suppose in milligrams it's 10 to the power 6. So what is 1 mole? So 1 mole is basically in terms of atoms or molecules. Why I'm using atoms or molecules? Because if I say 1 mole of O2 molecules, then it will essentially mean that it will have 6.023 in 10 to the power 23 particles. No, it will be molecules, because I said what, 1 mole of O2. O2 is what? O2 is molecule. So it will also have 6.023 into 10 to the power 23 molecules. If I would have said that 1 mole of, suppose, X element, X, and X the atom. So how many atoms will it have? 6.023 into 10 to the power 23 atoms. Now if I tell you that find the number of molecules in 1 mole of X atoms, is there any relevance? Because I am comparing, suppose, uh, atoms with molecules. Is that can be said? Certainly not. We can't compare unlike things. So you will say that's unlike things. Yes, they are unlike. Atoms do not have any individual identity when they're taking part in a reaction, whereas molecules do have. Okay. So, sir, what is the so please gist me down. What is the thing you are saying? I'm saying that 1 mole of H2 will have 6.023 in 10 to the power 23. It is also called what? It is also called Avogadro number. Avogadro's number. Okay, we can write it as capital N also. Okay, so 1 mole of H2 will have 6.023 into 10 to the 23 molecules. Same goes for O2. 1 mole of O2 will contain 6.023 into 10 power 23 molecules. Means the number of molecules in 1 mole of H2 and 1 mole of O2 are numerically the same. But you can't compare n particles of H2 with n particles of O2. They are mismatched, so you can't compare it that way. But the numerically they are same. Okay. Okay. Another way of defining this thing is atomic or molecular weight. See, I can say you details about the 12cc carbon atom also, but for easier interpretation, you just need to know the atomic or molecular weight. If it is an atom, then atomic weight, and if it is a molecule, then molecular weight. Okay, so what is the atomic weight? You know that every element can be represented like Na2311. It represents the atomic weight, atomic mass or atomic weight of the particular atom. And what is that in the case of a compound like H2O? We will just add up the atomic weights with the numbers also present in the number of molecules to get the atomic weight. Like suppose in H2O, what is the weight of one H? That is what is the weight of one H? That is 1, and there are 2 atoms, so 2 into 1. And what is the weight of one oxygen atom? That is 16. So what is the molecular weight of H2? That is 18 gram. Okay, we need to convert it into gram to say that it belongs to 1 mole. You're getting confused, so don't be confused. Just write the atomic weight or molecular weight, transform into gram, and that thing corresponds to the weight of one molecule of that substance. Like I can say, I can say 1 mole of H2O. What will be its weight? Its weight will be 2 hydrogen atoms, so 2 into 1, and oxygen has 16, that is 18. we will transform it into grams, and it will have 18 grams. So 1 mole of H2 in terms of weight, it will have 18 grams. Now, sir, you will say, sir, 1 mole of H2 and 1 mole of O2 and 1 mole of H2 has same number of molecules. Okay, 6.023 10 to the power 23 molecules. Okay, so will their weight be equal? No. You can see it. 1 mole of H2, what is its weight? Two atoms of each, means 1 mole of H2 has weight of 2 grams. But 1 mole of O2, what is its weight? 2 into 16, that is 32. So 1 mole of O2, its weight will be 32 gram. So we can't make that comparison in case of weight. But in the terms of number of particles or number of molecules, we can say they're numerically equal, but not in the case of weight. I'm revising it again. 1 mole of H2 and 1 mole of O2 will have the same number of molecules, that is 6.023 in 10 to the 23. But will the weight be equal? No, sir. 1 mole of H2, its weight will be 2 grams, and 1 mole of O2, its weight will be 32 grams. I guess you have got this idea. And there is another term, means I will share the next slide. It is very much confusing for you guys. Don't worry. So 1 mole or any mole can be expressed in 3 parameters. Like you have what? Like you are a human being. You have 3 parameters: height, your weight, and suppose what is another parameter you have? Your another parameter is your width. How much wider width? Suppose take it like that. So 1 mole of what, 2 mole, 3 mole, or any moles can be expressed in 3 parameters. Weight we have discussed. Atomic weight. 1 minute. In terms of atomic weight or molecular weight. In terms of particles, 6.023 into 10 to the 23 Avogadro number. Another important thing comes into the play is that is only for the gases. 1 mole of any gas. Another thing, 1 mole of any gas, 1 mole of H2, 1 mole of O2 will have the same volume, that is what, 22.4 liters. It is a standard thing. And at what temperature, at what pressure? At STP. At STP. What is the meaning of STP? STP is standard temperature pressure. What is standard temperature pressure? Temperature is 298 Kelvin or 25 degrees centigrade. And what is the pressure? 760 millimeter of mercury or 1 atmosphere. Okay. Okay. So 1 mole of H2 and 1 mole of O2 will have 22.4 liters. So here also the same. They will have the same volume. Achha, okay. Can I say that 1 mole of H2O will have the same volume? We can't, because it is only for the gases. It can't be said in the cases of liquid or any solid. It is only for gases. So 1 mole of CO2 will have same. Yes, 1 mole of CO will have the same, 22.4. So I guess you have got some idea about the mole concept. Mole can be represented in 3 formats: weight, number of particles, and volume. Okay, number of particles 6.023 in 10 to the power 23 corresponds to 1 mole. What is the weight corresponding to 1 mole? That is the atomic or the molecular weight. And for volume, 1 mole of any gas corresponds to 22.4 liter of that thing. Okay, so sir, if it is said that 2 moles, then simply 1 mole, then it is your unitary method. 1 mole corresponds to 6.023 in 10 to the 23 molecules. 1 mole of something X molecules, 6.023 in 10 to the 23 molecules. Then how many atoms or how many molecules will be there in case of 2? Multiplied with 2, means it is, if it is 1 mole, you will say this thing, and if it is 2 mole, then 6.023 10 to the 23 into 2, or 3 moles into 3. Suppose in the question you are given you have this amount of molecules. So how we will get the moles? Divide by 6.023 into 10 to the 23. That is Avogadro number. Just unitary method, nothing else. Suppose your weight is given, suppose for oxygen your weight is given, so 64 gram. 64 gram. You will say, sir, what is the number of moles? Simple. 32 grams corresponds to 1 mole of O2. 64 grams will correspond to double of it, 2 moles. That's simple. And if you suppose it is given that 3 moles of O2, then what will you do? What is the molecular weight of O2? 16. 3 into 16, that is 48. We can go reverse, no? From multiplication, we will go from 1 mole to number of particles. Multiplication, we will go from mole to number of amount of weight in grams. And similarly, for in the case of volume, if there is 2 mole of something x gas, then how much volume? 44.8. 2 into 22.4, that is 44.8. And if it is given that, suppose it is given that 67.2 liters of something gas is given, so what will you do? 67.2 divided by 22.4, that is 3 moles of that thing. Simple, nothing problem. Okay, I guess you have got some idea about these things. So we will discuss much deeper into this thing in our next subsequent classes. I will bring you some problems that will make you much more conceptually enhanced, because without solving, nothing can be done. Okay, first of all, nothing can be done. So let's endeavor our journey. Enjoy. We will come with another video. Okay, bye till then.